Hello and welcome to Cisco Support Community Google Hangout. During our event today, our speaker will talk about enabling your network for IPv6. My name is Qiming Huang, and I'm the product manager for Cisco Support Community here at Cisco. Our expert joining me today is Harpreet Singh, a solution architect at Cisco. Hello, Harpreet. Welcome to the Hangout.
Hello everyone.
Now I would like to briefly outline the format for today's Hangout. Harpreet will start with a presentation on IPv6 for the first 45 minutes. Afterwards, we'll dive into the question and answer sessions for the remainder of the event. During our presentation, you may submit your questions on the Google Hangout event page. So start posting your questions now to give it a best chance of being answered by our experts. Let's get started now. I would like to hand it over to Harpreet, who will give an introduction on IPv6. Go ahead, Harpreet.
Thank you, Kiming, and welcome everyone. Today we would talk about approach to IPv6 deployment, and this is not very specific to service providers or enterprises. Would apply to both of these scenarios. So the agenda that I'm briefly trying to cover, I tried to, let's try to cover the who is impacted, what do we have to do, where do we have to do things if we want to deploy IPv6 on that network, when do you have to do it, why. So there's a whole lot of questions to be answered, and then towards the end we'll wrap it up with a Q&A session. But that's the reason that we're talking about it today. Basically, we've run out of IPv4 addresses, and that is at a point where just 33% of the world population today is connected to the net. So if you look at this graph out here, it basically shows the blue dots show the population per continent, and the red dot in the middle shows the population that is actually connected. And with a whole lot of scope and the expansion that is happening in the third world and the developing countries, we would need a lot more IP addresses than we have today. And it is not just population. We're not connecting people, but today we're talking about the Internet of Things. And hence, when Cisco did a survey, and we figured out that the number of devices that are connected to the Internet, and hence the devices that need IP addresses to connect, is far more than the world population. And it is estimated that about 2020, you will have about 7 devices per person on Earth that need an IP address and need to connect to the network. That having said, let's look at what is it, or what do we need? Why are we saying we need to move to IPv6? Is it just IP address exhaustion? Because we started doing IPv6 in the mid-90s. We've been talking about it for a long time. So what are the top 10 technical reasons to migrate to IPv6? No doubt we're talking about a huge address space, but in addition to that, we're trying to solve a lot of other problems like operational simplicity and providing device auto configuration abilities by doing things like stateless address auto configuration. We are trying to eliminate NAT and provide an end-to-end IP experience, an end-to-end transparent IP experience. At the same time, we're also trying to do simplified header format, which will actually lead to efficient packet handling at the routers, because we've eliminated a lot of redundant fields or unnecessary fields from an IPv4 header. And at the same time, made the IPv6 header more deterministic by chaining the extension headers rather than by keeping it as options within the IP header as used to happen in IPv4. Again, there are a whole lot of things that were designed early on in the architectures to talk about hierarchical network architectures, provider assigned addresses and provider independent addresses. There were talks about better security, better QoS, but then not all of them might be valid today, because we are about 20 years down the line, that when the specs were originally drafted. But just to call it out, IPv6 is only an enabler. It's not going to change anything fundamentally. What a user experiences on the network is not IPv4 or IPv6. He has an experience, and that experience can be delivered on IPv4 or IPv6. It's just an enabler, and what will determine the adoption of IPv6 is new applications that will come in. Think of all the smart grid applications, think of connected communities, think of connected devices. So all of that is something that will actually lead to adoption of IPv6. Having said about what are the IPv6 enablers, what is it that changes with this IP version? Now, there's a lot of confusion around when we go and talk to customers and talk about you need to change, you need to migrate to IPv6. And the first thing that comes across from a customer is it's just a version change on the network. You're changing something at the network level. So what is it that I need to change? So let's look at what is it that you're doing with IP. You have the network running some sort of applications, and then those applications are delivering some sort of services for an end customer. Then you have two of these. So you have a client side of it, you have a server side of it. So these two machines then talk to each other via the network. Now, we are changing something at the network layer, so we are creating a different protocol, a different version of a protocol. So you're moving from IPv4 to v6. But then the network consists of network devices, and then this network functionality is enabled on the end devices through operating system and IP stacks or TCP IP stacks within the operating system. So it is but natural that all these three would change. You would need some changes in the network devices. You would need some changes in the operating systems as well. Is that all? Let's look here. So how do the applications talk to the network? They invoke a certain set of APIs, right? So they invoke a certain set of APIs or sockets, as you would call it in the programming parlance, and those socket structures need to change, which means if you are enabling IPv6 on the network, it is not just the network, but the applications as well, which will need to be validated for being able to run seamlessly over an IPv6 infrastructure. And in addition to that, there will be a whole lot of supporting services that are running on top of the network. Say, for example, DNS, the domain name system services that are running on the network, which enable you to map a particular domain name to an IP address. So if you're changing an IP address, you need changes to all those supporting services. Let's look here as to what happens if both of these stacks, you have a client side and a server side, are talking two different languages or two different protocols. If one talks IPv4 and the other thing talks IPv6, you need some sort of a translation in between. And that translation is something that you call protocol translation. So there's a whole lot of dependency beyond the network which is required if you want to enable IPv6 on top of a network. So we've decided we want to go to IPv6, but what are the challenges to transition? If you look around and go to any of the address registries, IANA, the IANA that provides IP addresses to the regional registries or the regional internet registries, ran out of the global IP address pools sometime in 2011. Apnic was the first one to run out of IP addresses around the first half of 2011. And then we saw that the only IP addresses available, the global public IP addresses available from registries today are IPv6. That's one part of the story. The other part of the story is that majority of the user devices that you have today, majority of the content that you have today is IPv4 only. Majority of the service provider connectivity to their customers is IPv4 only. So there are two contradictory forces that come to play here, meaning you have a lot of legacy IPv4. However, for growth, you need a whole lot of IPv6, and that's the only thing available. What else? Operating systems. All modern operating systems that you see are fully IPv6 capable. Take Windows, take Mac, or most flavors of Unix. They're all v6 capable. However, look at the actual install base of the operating systems that have a very limited IPv6 support, or maybe no support at all. And then SPs need to grow their network using IPv6, but most importantly, the biggest inhibitor or challenge to transition, and that's something that we've seen customers delaying IPv6, is there's no additional ARPU by deploying IPv6. It's a cost for a service provider, yes. It's a cost for an enterprise, yes. But the moment it comes to creating a business case for it, it becomes difficult for an ordinary organization or ordinary enterprise organization, let's say, to go and deploy and justify the additional investment by deploying IPv6. So this is, an example of saying what happens when you migrate. So when we migrated from black and white television to color television, right? So instead of seeing color, if you just saw snow, that's not what was expected. You expected things to go and work backwards. So what was expected was that you had some sort of a backward capability in the system like all other protocols. You had newer versions of BGP coming up, you had newer versions of ZIP coming up. So you had any protocol that you look at was always backwards compatible with the previous version. Unfortunately, the moment we move from IPv4 to v6, the only backwards compatibility that you have is this, meaning v4 going in one direction, v6 going in the other direction. And this picture might look funny to you, but if you actually go back into specifics and you try to figure out how dual stack works on a machine, this is exactly how it works. You try to establish a connection on IPv6. If it works, perfect. If that engine doesn't fire, you are not going to your destination through a particular path. You fire the other engine and you start going in the other direction, which is IPv4, and you try to reach your destination, right? So that's the biggest inhibitor and the biggest challenge why we are talking a whole lot about how to migrate to IPv6. Now, there are again fundamental differences around how and what changes when you talk about IPv6 deployment. There are different perspectives to IPv6 deployment, and these perspectives come from who you are. If you're a service provider, you'll have different challenges. If you're an applications developer, you'll have a different challenge. And if you're an enterprise, you'll have a different challenge. So there'll be different perspectives depending upon which glass are you looking that problem with. And from a consideration standpoint, you would talk about protocol changes. So what changes at a protocol level? And there's a whole lot of not only learning that needs to be done from v4 to v6, because if you talk to a network engineer today who's been doing IPv4, it becomes slightly complicated for him to go back and understand v6, because you're now taking him away from a dotted decimal representation to a hexadecimal representation. You are telling him there's no broadcast, right? It's all multicast. So if you look at those whole lot of protocol changes that have happened, there's a lot of unlearning and learning that has to be done. There are a lot of DNS changes that need to be done from the perspective of enabling quad A records on DNS servers. There are application considerations, there are operating system considerations, but then like any other network change that a network administrator does on a network, The single biggest fear of a network administrator is, what if the existing network goes down when I try to enable a new feature on top of my network? So you have a network running IPv4, let's say having, for the sake of simplicity, 100 IPv4 routes in the routing table. It's running on a certain CPU and memory consumption. And all of a sudden, you try to go and dual stack your machines, meaning you provide an IPv6 address as well to all your devices. What next? Would that suffice? You had 100 IPv4 prefixes. You provided additional 100 IPv6 prefixes now to be held in the routing table, which means you need more memory. Theoretically, given that an IPv6 address is about 4 times an IPv4 address, you need far more memory, not just double the memory that we're using with IPv4. You need more memory to store not only v4 but v6 addresses as well. You need more horsepower on the machine because you did not switch off IPv4, you added something on top of IPv4. So would your device be able to support the hardware, be able to support all the additional processing that you are trying to do on top of your devices? Or would you need some sort of an upgrade? Would that upgrade be a hardware upgrade or a software upgrade? And in addition to that, would there be any interworking required? Would you need the IPv4 clouds to talk to IPv6 clouds within your network or even outside your network? And not just so, every perspective that we've listed on the left-hand side would have a certain set of considerations to take care of on the right-hand side. So depending upon who you are and what are you trying to deploy IPv6 for, you will have a different set of problems. So if I look at the network, what is it that you need to, what is it that the network does for IPv6? A network basically takes packets from one endpoint and transfers it to the other endpoint. Is that what you want to do? Yes, you want the network to be a packet transport as fast, efficient as possible, and providing you the quality of service. So the deployment approaches in the network could be as simple as running an IPv6 only network, which might not be very practical because you do not want to switch off IPv4 today. It could be the next simplest form, which means you already have IPv4 on your network, dual stack everything and run IPv6 on top of the same network. So you're running IPv4 and IPv6. The other thing that you could also potentially do if you were transferring and transporting or deploying v6 in the network is tunnel these networks when you need to. So let's assume you had an IPv4 network. If you recall what happened when we tried to create GRE tunnels or IPsec tunnels from one endpoint to another and treated them as logical links on the devices. You could still have IPv4 tunnels connecting IPv6 islands and treat them like IPv6 logical interfaces. The other way of looking at it is, if you don't want to create IP tunnels, having MPLS simplifies your problem because, and that's where the power of MPLS comes in, and that's, other than transporting ATM frame relay, this is where it actually becomes multi-protocol because you have an underlying infrastructure, you give IPv6 packets to it, it seamlessly transports those IPv6 packets by just putting a label, and your underlying infrastructure might just be IPv4 only. And if you look at most service providers in the world who are, which are MPLS enabled, that's the easiest thing for them to turn on because you just have to turn on 6PE or 6VPE and then you are actually ready to transport IPv6 prefixes. And then the other thing is on the network is about what do you do for protocol translation, which is about allowing v6 only devices to talk to v4 devices and vice versa, which is again moving towards standards in the ITF. So that's the network side of the story on the packet forwarding side. But there's a whole lot of other things that you need to do from a network standpoint. You need to take care of domain name systems, you need to take care of any application layer gateways, any NAT that you need to do. So, and again, when you're trying to do NAT, if there are customers who were or service providers who wanted to extend the IPv4 address space that they had, they typically went in with NAT and they wanted to, there were newer terms that were called out, meaning here is NAT 4.4, meaning you NAT a private IPv4 address to a public IPv4 address. And then there were things which were called LSN, large scale NAT, or things called CG-NAT or carrier grade NAT, meaning you could do a NAT functionality at much larger scales and with carrier grades of availability and performance. And at the same time, the providers actually resorted to doing something like NAT46, which means you take an IPv4 address, convert it to an IPv6 address, and then send it out over an IPv6 infrastructure. Like any NAT solution, typically, if you look at a stateful versus stateless NAT, any device would be constrained the moment you try to do something which maintains state. So stateful NAT would start being a bottleneck as and when you start going up that scale magnitude, and hence there was choices between, do you want to do stateless NAT or stateful NAT? Stateless NAT meaning you do not have to maintain state. So the easiest example would be you just take the IPv4 address, add a IPv6 prefix aggregate to it, and you convert the IPv4 address to an IPv6 address. Also meaning that by just looking at the IPv6 address, you could identify what the IPv4 address is. And then from a service provider standpoint, you would see problems like lawful intercept coming in. How do you do logging? How do you do capturing and storing? Because there are regulations around storing NAT logs, or even who's doing what on the network for longer durations, maybe up to a year. How do you do DPI from a service provider standpoint? What is the cost of a CPE if you are actually going back and providing services to your end customers? So all of these things, if you look at it, the top three actually define or contribute to what the user experience is, and the bottom four out there actually have an impact on the CapEx and OpEx requirements of a service provider. So all of these things are very, very critical and deciding factors in how do you want to go back and choose a solution which will help you deploy IPv6 on your network. And a term that we've seen customers asking very often is, I want to migrate to IPv6. Now the point is, you're not migrating today. You're not, the two will coexist for a long time to come. So there was an era when you were talking IPv4 only. There will be an era when you'll be talking IPv6 only. However, the interim period will be a dual stack period wherein you will have IPv4 and IPv6 both. So during the interim phase, you would need a lot of interconnectivity through gateways or translation mechanisms to talk from IPv4 to v6 and v6 to v4 and vice versa. So in the real sense, it's not actually a migration but coexistence that we are looking at for a long time to come. Having said that, the standards, the RFCs actually define multiple scenarios of communications between IPv4 and IPv6. So if you look at the dotted rectangle on top, you're looking at an IPv4 cloud and an IPv6 cloud. I've just shown those two clouds separate out there for logical representation. However, at a physical layer, it might be a dual stack device. You might have a same device having an IPv4 and v6 address on the same interface. So from that perspective, it could be physically overlapping, but logically two different clouds. And this could apply to an enterprise, could apply to to a service provider. So basically, let's look at that as an autonomous domain. So if you were talking between IPv6 and IPv4, you need some sort of a translation device and a DNS, and then at times most of these are coupled or decoupled depending upon what is the methodology that you're using for converting and talking between IPv4 and v6. At the same time, the enterprise might be connected to the IPv4 internet and would be talking to the IPv6 internet as well. So the standards actually define that you could actually end up having 8 different combinations of traffic flows depending upon where is traffic originating from and who is actually trying to establish a connection. So for example, if you look at the number 1, the arrow that I've numbered 1, which is the blue colored arrow out there, actually shows a communication which was initiated from an IPv6 client within the enterprise, and he wants to go and access the IPv4 internet. And 2 is where somebody from the IPv4 internet tries to access a server or a machine which has an IPv6 address within the enterprise. So depending upon any of these scenarios, there are different standards and different techniques that address each of these problems from a deployment standpoint. However, 7.8, which is about anybody talking from IPv4 to anybody talking IPv6, is still not possible, because if the day we get there, we would probably not need anything else, and it'll be a seamless connectivity all across. So now let's look at what does it take to deploy and what are the options available. I've taken an SP network for the sake of completeness, because if you look at an enterprise would be a subset of this. So you'll have a service provider network in between. You will have a user network on one side, or the home network on one side, meaning you have a CPE, and then you have a user network behind the CPE. You might also have a wireless network on this side, on the customer side, and then you are actually talking to the IPv4 internet and the IPv6 internet. So what is it? Well, from the user perspective, you could have an IPv4 only address, you could have an IPv6 only address, or you could have a dual stack address. And even when you have an IPv4 address, you could have options of saying, do you want to assign an IPv4 private address or an IPv6 public address to the end user? Meaning, do you want to do NAT at the home gateway or the CPE? The way it depends on the way you want to call it. On the service provider network, which is actually supposed to be a transport network and would transport packets from the CPE to the IPv4 or the v6 internet, what are the choices available for the service provider network? Do you have an IPv4 only network, or do you have an IPv6 only network? Do you have a dual stack network? And again, the option that you don't see here is maybe you have an MPLS network here. And then do you need to would you transfer packets across from the user to the internet edge or the actual internet cloud as it goes out from the service provider natively? Would you route them, or would you do some sort of a tunneling? That tunneling could be within an MPLS packet, or could be an IP in IP tunneling, meaning you could do an IPv4 in IPv6 tunneling, or you could do an IPv6 in an IPv4 tunnel. And then at the edge, do you want to do some sort of a translation? Depends upon how many IP addresses do you have. Did you do some sort of an address translation at the CPE or not? Do you want to do a double translation? And if you want to do a translation, Is it NAT 4.4, meaning IPv4 to IPv4? Is it NAT 4.6? Is it 6.4? And then again, coming to that point of scale, is that translation stateless or stateful? So if you look at all of these options from a deployment standpoint, you would actually end up saying, do you want to do NAT 4.4? NAT 4.4 is something that we've been doing for a long time, which means you have an IPv4 address, you translate it to an IPv6 address, you do native IPv4 forwarding, and you assume a single stack network. But then there's no IPv6 here, so let's discount that option. The other option is dual stack, meaning give an IPv4 and IPv6 address to both. Your network is IPv4 and v6 both, and depending upon if your customer is IPv4, you transport it natively using IPv4 part of your IPv4 logical part of your service provider network or transport network, and if your user is IPv6, transport it natively on IPv6. The third option that you could be looking at is a DS Lite option, which is a dual stack Lite option, meaning you build an IPv6 only network and your CPE is DS Lite enabled. It has an IPv4 address. However, that IPv4 address gets tunneled in an IPv6 packet as it goes from the home gateway to the border router or the gateway router, as it is called in that terminology. However, the problem is, we are all familiar with the problems the moment we get into tunnel saying there's no multicast support because every tunnel is terminating on the gateway router, and hence if you were to do multicast, you could not take the full advantage of multicast, and that is restricted because it's all between tunnels. The other option that you could also be looking at is a 4RD or a 4 residual deployment option, which again means you have an IPv6 network with A plus P, which is address plus port translations, and you could still do IPv4 and IPv6. Again, depends upon, you could do a NAT 4.4 on the CPE. Again, because this is tunneled, you do not have any multicast. And the last option that you see down there is an IPv6 over an IPv4 network, which is an IP in IP tunneling, meaning the basic network is IPv4 and your endpoint is IPv6. You are taking IPv6 addresses, transporting them in IPv4 tunnels, and then taking them out. Again, that's 6 rapid deployment. So it depends upon what stage of the network evolution you are in. If you have a natively IPv4 network, you could look at 6RD, which is rapid deployment. You could go and deploy IPv6 pretty quickly for your end customers. However, if you're starting afresh, you could look at building an IPv6 network to start with. You could look at DS Lite or 4RD or MAPT, which is again a draft software in the standards today. And maybe you could also look at dual stacking the entire network infrastructure. On the NAT side of things, the options that you could again do are, do you want to do NAT 6.4, which is a stateful IPv6 to IPv4 translation. Now, quick to do, but then poses those challenges of scale. You could do a one-to-one NAT 4.6.4, meaning IVI as this is called. IVI as in Roman IV is 4 and Roman VI is 6. So if you look at that, its IVI is 4.6.4, meaning you have a NAT 4.6 at the CPE and NAT 6.4 at the central gateway. You don't need any tunneling for this. So what you could essentially do is you could have a native IPv6 only network. Your endpoint could be IPv4. You create or you do NAT 4.6 at the edge at the CPE device, convert that IPv4 address to a v6 address and push it out. And the border gateway then again takes that IPv6 address, converts it to an IPv4 address. And then you could do a NAT, a large scale NAT if you have to do something. But the problem by doing IVI or one-to-one IVI is that this is again a one-to-one NAT. So the basic problem that you were trying to solve, which is about IPv4 address exhaustion, is something that you've not solved, right? So the other thing is you could do an IVI with a similar to NAT overload that we used to do in IPv4 networks, which means you take NAT4.6 on the CPE and do a NAT6.4 with an address plus port on the gateway router. And the last option that we could be looking at is a dual IVI, which means I do a NAT4464, and that's a NAT44 at the router, similar to what we did, and then do NAT64 again with address plus port translations. Easiest to do because all of these mechanisms that you're talking of, IVI, NAT overload, or DV, they're all stateless and hence far more scalable and scalable to do. And the other thing is because they are stateless, you don't need state. The IPv4 address gets embedded in the IPv6 address, and hence, even from a logging perspective, they are much more easier to track and log, even from a legal interception standpoint. So if you were to just do some sort of a solution comparison around technical superiority and ease of operations, you would probably rate IP native as the highest in terms of ease of deployment or operations. And on the technical superiority side, we would still call MAPT or the 4464 as being technically superior from the perspective that, for somebody who's coming up on a greenfield network, you could still have an IPv6 network infrastructure. But again, from an enterprise standpoint, all of these things might not be very relevant. And from an enterprise standpoint, you might just need to look at dual stacking your network, at least in the unless you are a very large enterprise who's actually doing some sort of an MPLS or a service provider type of a network in the global space. Now that was on the network side of house. What about beyond the network, right? We talked about an application developer's view. So I guess this is the first time that even within the IETF, we have had a lot of focus around what changes on the application side. There are RFCs available which talk about the socket structures that have changed. What are the sockets and what are the routines and functions that have become obsolete, and what are the functions that we need to call if you are writing or porting an application from IPv4 to IPv6. So basically, you are saying you need support for IPv6 sockets, fundamentally because even from an application standpoint, the simplest of things that an application developer used to do was just code a colon 127.0.0.1 as the loopback address, and most of the things worked with that. Now, the moment if you hard coded something like that, those things will not work with IPv6 because IPv6 has a totally different address structure, and you need a colon 1 to identify that loopback address. So depends upon how that application has been coded that things will have to change here. Operating system and support systems. Now, it's pretty easy for somebody to go back and say, I support IPv6, but the point is there's a whole lot of features out there that you actually need to look out for if you're talking, are you IPv6 ready or not? And I just took a snapshot from Wikipedia. I've actually put that link down there to figure out how many operating systems and versions claim IPv6 ready and what is it that they don't do. So for example, if you're saying Android 2.2, which is again a pretty outdated version, but just to give you that example, you're saying if it says I'm IPv6 ready and you do not have support for neighbor discovery or DHCPv6, imagine if you would actually want to call it IPv6 ready. So depends upon what is it that you actually want to do with the operating system or on that operating system that you've got to evaluate what are the features that you need. It's not about, you know, one device doing everything, but what is it that you want to do with that device and or operating system, and would that device or OS be able to do that function? Now let's come to how do you want to do this? Now, we've talked about the service provider options, we've talked about an enterprise option at least, and I'll give you a case study in a moment. But that case study would more be an enterprise centric stuff. So, but basically, this slide applies to both a service provider or enterprise. It's a uh, it's a generic slide talking about how do you want to approach the IPv6 migration problem. First of all, you've got to figure out what is the effect on the business model, because the network is not there for itself. The network is supposed to be running services which are there to support businesses. So, what is the impact of this migration on the business model? Having done that, the first thing that you probably would want to do is establish a project management team and assess your network hardware and software to be able to figure out, would these devices that you have in the network be able to support IPv6 from a hardware and software perspective, or would you need some sort of an upgrade? So doing this early on in the network would give you a fair idea about the budget requirements and the costing requirements that you would need to be able to go back and do an IPv6 deployment on the network. Parallelly, you might also want to look at an IPv6 training strategy and obtaining IPv6 prefixes from your route registrars. And then comes the actual, the geeky part of it, which is about deciding what the IPv6 architectural approach should be for the IPv6 network. Depending upon what is it that you want to do, you actually go down to testing your application software and services and develop your security policies, because security in IPv6 is very, very different is from the security that we used to do in IPv4. Just to give you an example, we blocked IPv4 summarily in an IPv4 network, whereas typically, if you were to block all ICMPv6 in an IPv6 environment, nothing would work, because IPv6 uses PMTUD or path MTU discovery to establish what the MTU is that will be supported over that end-to-end connection. And the most important step, that people typically tend to forget is, do we have an exception strategy to migrate to IPv6? Meaning, is there an application that needs to be phased out? Is there anything in the network that the cost of upgrading which to IPv6 exceeds the benefits, and I can replace that with a newer device? Is there an application that I'm actually phasing out? Is there something that I will say, here is a set of things that or a part of the network that I will not enable for IPv6, and I will leave it on an as-is basis, right? So here is a case study of what was done for enterprise here in, so the first thing is, it was primarily aimed at enabling the data center infrastructure for a customer for IPv6. And the first thing that was done was the hardware and software assessment. So you look at all the network devices, you look at how many routers, how many switches, firewalls, load balancers, anything that touches the network. Are you IPv6 capable? If not, can the device be made IPv6 capable through an upgrade? And that upgrade could be either a software upgrade, or could be a memory upgrade or a line card upgrade on that line card or device. In addition to that, we also have to look at the application assessment summary, because it's not just the network but applications as well, talking about how many operating systems or different versions of operating systems do you have, how many types of databases do you have, how many types of application softwares do you run on top of your network, and assess that. And having said that, The next thing that you do is migrate and map those application components to business processes. Say, for example, a business process for e-commerce for a particular site might be talking multiple tiers, might be talking web app DB, might be having a crypto algorithm or application in front of the web gear as well. You might be doing everything in your data center. You might be outsourcing or offloading some part of it to a managed hosting provider. So once you've mapped each of these applications into business processes, you would get a feel of how many devices or applications or at a business process would I be able to convert back to IPv6. And then comes the actual tricky part of it. And this is where you spend a whole lot of time for lack of documentation typically in networks, because the teams are so fragmented across applications, across network and security, that you spend a whole lot of time defining and finding out what the existing flow is. If a user sends an IPv4 packet, what are the different devices that you traverse? How do you traverse? What is it that you do at each device? And once you've identified these flows, you actually go and create what the steady state flows would be if you were to do an IPv6 only network. So you have an existing steady state existing flow, which is an IPv4 flow. You've defined how do you want the final flow to look like, meaning what is the steady state flow, and then comes the interim part, meaning how can you make sure that if there is a device which needs to do some sort of a translation, at least for now, how do you do that translation? Where do you place that device? Can you make sure that that device would handle only packets? You could have something like a hairpin and send only packets that need to be translated back to that interim flow. So once you do all of this, you'll be able to get to an end-to-end view of what you want to do on top of an IP network to do this. So just to summarize, you'll need to take a phased and an iterative approach to IPv6 adoption. Basically, identify the highest priority critical area in the network. For example, in this case study, we talked about just the data center part of it, because for an e-commerce site, that's something which is the most important part, and the business actually depends a whole lot on the data center part of it. Perform your IPv6 assessment on it, develop a design, and then after you've done a pilot and deployed it, go back to the next critical area in the network. And again, remember to follow those 10 golden rules that you had to start with. So net, in summary, we are saying V4 to V6 is no magic. It's just 96 more bits. But in the end, it's a bit too much to do in a night. And hence, we've got to be agnostic of the fact, and that the right planning in the early stages would help all of you to enable and migrate or deploy V6 on your network in a much smoother manner. That's what I had, and if you have any questions, Kimming, we can take them now.
Thank you, Harpreet. Okay, so yes, we do have some questions.
So I have a question here, which is about the different strategies used by mobile providers migrating to IPv6 and how to overcome the limitation by different handsets which do not support IPv6. So again, we have seen service providers in this part of the world and even globally. One, if you have an IPv4 only handset, depending upon what mobile technology are you using, are you just on 3G or are you doing LTE? So depending upon whether it is a GGSN or are you doing a P gateway sort of function, right? So the moment you have an IPv4 packet coming out, typically the only option that you have, if you have an IPv4 only device, because the infrastructure could be anything, honestly, because the only thing that you're doing is you are tunneling that packet the moment it comes out from the SGSN to the GGSN, right? So you're creating a GTP tunnel and then sending that packet out. So depending upon what IP address you gave to the end handset, you would have that packet coming out, and then you could do a sort of a translation NAT64 if you want to go and access from an IPv6 device to a V4 device, or you could do other sorts of translation. And protocol translation is the only thing that will help you talk between IPv4 and IPv6 clients. There's another question that I have, which is about I'm trying to find a good global design plan for IPv6, since multiple ISPs will assign different IPv6 blocks at different locations of the network. So the easiest thing to do in such a scenario is if you're a large enough organization, what you could do is you could take a global IP address pool, which is a provider independent address space from your address registrars. And having done that, you could take pools of IP addresses, you could still subnet them into smaller prefixes and advertise them from different geographies. So for example, let's assume you got a /32 from your registrar. What you could do is you could take that /32, split it into smaller blocks, and the smallest block that you could advertise on the IPv6 internet today is a /48. So you could take a /32, break it into let's say 36 or 40, or depending upon what your plan is, and advertise those, let's say from Asia Pac if you're appearing in the Asia Pac, and a different /40 from the US if you're appearing in the US as well. Things get pretty easy if you are just peering in one geography, because then you do not need to do different pools of peering. But it's the same addressing policies that you would use in IPv4 that would apply to IPv6 also. Now that having said, you could also look at doing ULA addresses within your enterprise, so that you have a global pool for your data centers across geographies, and you can use ULA, which is an RFC 1918 equivalent addresses in the IPv6 address space, which is FC, which starts with FC00::/8 and FD00::/8 to use within your network, and have smaller global pools which are which could be provider assigned as well, and you could take them with the people that you peer with locally, and you could do some sort of a proxy server to go out to the net. The next question that I have is, do we have different classes in IPv6? Yes. So similar to IPv4, you also have different classes in IPv6. So you still have the TOS bits in IPv6 to provide quality of service within IPv6 as you would do in an IPv6 environment. So quality of service still applies to IPv4 and IPv6. Okay. Any other questions that we have, Jimmy?
I think that's all the questions we have for today. I don't see any new questions on the event page. Yeah, I think you just answered all the questions. Thank you so much. And I think I probably pronounced your name wrong. Should be your last name should be Shang?
Singh.
Singh.
I'm
sorry.
Harpreet Singh. Yeah.
Yeah, Harpreet
okay.
Singh. Yeah. Okay. So, thank you so much. Thank you so much, Harpreet. I think that's all about the time we have today for the Q&A session. And if anyone joining the session today have any additional question, or we didn't get a chance to answer your questions, you may head over to Cisco support community on Google Plus or on Cisco.com. We have listed the URLs there on the event page today, and you can find answers to many of your questions about Cisco product and services there. Thank you again so much to our experts, Harpreet Singh, for sharing his expertise with us today. It is a very informative session. Also, I would like to invite everyone today to our future coming webcast, which is going to be talking about Power View Network Control System. This is going to happen on Tuesday, December 10th, 2013 at 9 a.m. PDT, San Francisco time. And I just posted the event link on today's event page. Just make sure you sign up the webcast today on the Google Plus event page. We have sign up URL there. And we really encourage you to invite your colleagues and friends to our community and our future events. Again, thank you for joining us at our Google Hangout, and you guys have a wonderful day. Thank you. See you guys again next time.